I'm Alexis Navarro, and over this summer, I had the pleasure to conduct some research regarding software safety with the University of Texas at Dallas. So let's get started on what my research was all about. So my research focused on working with modeling languages and AI to ensure and enhance software security and safety. So, what are modeling languages? Modeling languages are artificial languages that use a set of rules to express information in a defined structure for software. Why are they so important? Modeling languages are important because they help us find key problems in the software, analyze and design solutions to fix security and bug problems in the software. So these are the different types of modeling languages that I came across when I was researching this topic heavily. So one of them being the finite state machine testing. So this is like mathematical models that can be used to test systems by checking each state and state transition. So a great example of this would be that there's a gate and the finite state would be locked and unlocked, and it's locked when no coin is put in. Once the coin is put in, it becomes unlocked, and that is the state transition. So the other big one would be unified modeling language. So this is a visual modeling language used to help visualize the back end of software and construct and design of a system. Design table testing used to analyze various input combinations and examines how a system will respond to various changes. Data modeling, process of creating a visual representation / blueprint that defines the system of a software. And may I say that all these four types of modeling languages are very important to the software security and safety of various softwares that we have now. So this is a standard unified modeling languages. We could see that you just input your stuff. So here if a graph grammar happens, you just skip these errors and you go to analyze security threats, mitigate security threats, and then security state chart. So this basically just tells you if this happens over here and you get this, then these are the steps that you need to do to make sure that the software is running correctly. So my research questions and goals of my whole research here would be number one, is there a problem that we are facing in softwares that are supposed to ensure security and safety? Number two, how would software processing methods be adjusted to ensure the safety and security in softwares? And my goals of this research was to analyze the importance of modeling languages and see the current faults in modeling languages. And this was really big. And while I was researching this, the whole Microsoft and the planes thing crash happened, and that was because of a software error. So my related work when researching this was what are some studies about using UMLs for software security and safety? So one, we can see the impact of artificial intelligence on data systems security and secure knowledge management and cybersecurity in the area of artificial intelligence. And so both of these articles state that many softwares are use supply chains. While supply chains are the backbone of multiple softwares, this is what causes those security issues in the softwares. A solution proposed by articles is UMLs. The UML provides us with a standard way to visualize, specify, construct, and document all the components involved in the supply chain. So more related work. So this research focuses on the core ideas of how machine learning, network science, modeling languages contribute to software security, along with the benefits and challenges of their implementations. Machine learning, essential for safeguarding software against attacks, helps identify patterns that could lead to data breaches, facilitates malware analysis to detect potential threats. Model languages would include a machine learning tool designed to help understand and replicate underlying data patterns, generate new data based on learned patterns, produce intelligence and incident reports detailing ongoing attacks, assist software developers in identifying areas needing improvement. And network science just is like the focus on studying complex networks and their interactions, so the connectivity. So this analyzes how network factors impact outcomes and helps navigate IA challenges. So my findings and provisions would be, although UMLs provide us with the visual structure of how to fix a software that has malfunctioned in the safety and security aspects, we find that large language models are quite effective when UML is lacking. Large language models provide us with detailed intelligence and incident reports, offering insights into ongoing attacks and helping developers training their systems. While generative models these models learn and replicate data patterns to generate new data, which can aid in predicting and mitigating security threats, which is all part of machine learning tools. Advantages of AI integration. Although we have focused on modeling languages to find a solution to enhance the security threats posed on softwares, we oversaw a key factor to helping us mitigate this risk: AI integration. With AI advancing, it's integrating into our world so fast. It's only like common and fair that we see that AI can help us like with software safety and security. And so we see in an article published by the University of Colombo, the integration of AI into threat analysis allows us to have fast analysis of security threats and AI rapid processing capabilities, enhance the identification and response of emerging threats. So here is an example of how we could integrate AI into UMLs. So this is a standard UML that you would see, but the help that you would need, you would just input what you need, so required text, and then it would design a whole UML using AI, telling you like these are the steps that you need to do. And again, this is an AI based UML diagram by the University of Colombo School of Computing. So my future work in conclusion, although my research is not quite finished, I have a grasp of what I want to continue doing, just because like this is a lot to work with, and in the future I would like to see more solutions. So my study just aimed to analyze and research the different types of softwares used when it comes to software security and safety. This was achieved by seeing that various softwares are now using AI to work in their favor, as well as deep learning, natural sciences, and most importantly, unified modeling languages. Based on the research presented through the methodology, it is present that UMLs are a key factor when ensuring a software is secure and safe. And that's all I have for you. Thank you so much. Yes, thank you so much. Bye.